Hello everyone, this is Colin from Fiber Optics for Sale. In this video, I will explain what are fiber optic attenuators. Fiber optic attenuators are used in applications where the optical signal is too strong and needs to be reduced. For example, in a multi-wavelength fiber optic system, you need to equalize the optical channel strength so that all the channels have similar power levels. This means to reduce stronger channels' powers to match lower power channels. Another example is when the received optical power is so strong that it saturates the receiver. You need an attenuator to reduce the power so the receiver can detect the signal correctly. This picture shows an example of a fixed optical attenuator. The attenuation level is fixed at 5 dB, which means it reduces optical power by 5 dB. This attenuator has a short piece of fiber with metal iron doping that provides a specified attenuation. There are many different mechanisms to reduce the optical power. This picture shows another mechanism used in one type of variable attenuator. Here, variable means the attenuation level can be adjusted. For example, it could be from 1 dB up to 20 dB. In this example, the light from the input fiber is expanded into a larger beam by the first collimating lens. Then a blocking device, which could be a neutral density filter, is inserted into the light path to partially block the light, so only part of the light can pass through. Then the second collimating lens is used to focus the light back into the output fiber. When you move the blocking device inward or outward, you get different attenuation levels. Fiber optic attenuators are usually used in two scenarios. The first case is in fiber optic power level testing. Attenuators are used to temporarily add a calibrated amount of signal loss in order to test the power level margins in a fiber optic communication system. In the second case, attenuators are permanently installed in a fiber optic communication link to properly match transmitter and receiver optical signal levels. Optical attenuators are typically classified as fixed or variable attenuators. Fixed attenuators have a fixed optical power reduction number, such as 1 dB, 5 dB, 10 dB, etc. Variable attenuators' attenuation level can be adjusted, such as from 0.5 dB to 20 dB or even 50 dB. Some variable attenuators have very fine resolution, such as 0.1 dB or even 0.01 dB. This slide shows many different optical attenuator designs. The female-to-female fixed attenuators work like a regular adapter, but instead of minimizing insertion loss, it purposely adds some attenuation. The female-to-female variable attenuators are adjustable by turning a nut in the middle. The nut adjusts the air gap in the middle to achieve different attenuation levels. The male-to-female fixed attenuators work as fiber connectors. You can just plug in your existing fiber connector to its female side. The inline patch cable type variable attenuators work as regular patch cables, but you can adjust its attenuation level by turning the screw. For precise testing purposes, engineers have also designed instrument-type variable attenuators. These instrument-type attenuators have high attenuation ranges, such as from 0.5 dB to 70 dB. They also have very fine resolution, such as 0.01 dB. This is critical for accurate testing.
Hi there guys, this is 2E0 VOV. I'm doing a little bit more homebrew. The intentions are that I'm going to build a attenuator today. I've nearly finished building this one. Just thought I'd finish showing you it as it comes together on the final process. Basically, this is to help me run lower power on Whisper, and this is a cheap box bought from eBay. I'll put flash a picture up on the screen so you can see where it's from. Comes pre-drilled on the ends so that when you put it together it will fit SO239 sockets. So that will just drop into place, snaps in, you put your screws in, and that makes you an attenuator. Now this obviously it will affect attenuation for in and out. I'm building for, as you can see, I'm building it for 10 dB. So in my case, this is to work with the Whisper beacon or a Whisper light. I've got, acquired a Whisper light as well, which still works as a beacon. So I'm only interested in reducing power from my transmission. So purely working on the theory, this is a going to be a pi network. We've got two 100 ohm resistors dropping down to ground in the center, and we're going to have a 75 ohm which will be soldered in series, so it will go from this terminal here, from the hot terminal there, to the hot terminal on that side, and we'll build a full complete pi network for 10 dB attenuation. Now the plan is that, as I say, this will run my Whisper, so I can run a 5 watt radio. If I wish, I could run a 5 watt radio. 10 dB would make it produce 500 milliwatts. You could run it as I'm planning to run the FT817 through this with 500 milliwatts. Give me an output of 50 milliwatts. One end tinted of the resistor, say it's 75 ohm, this particular one. 3 watt, by the way, 3 watt resistor. There we go, beautiful. So we'll just get this one into position. Right, so we'll reassemble our little box. So I say reassemble because I've already had it put together as a test run first to check how it would assemble and would it actually physically work with these components combined, and it does. So very pleased to say this is a nice type of box to use for this type of work. There we are. So we've just got to put our screws in the end and the unit's built. Right, anyway, so thanks for checking by. As I say, this will be pressed into service for my future use of Whisper. I will be doing some tests, A and B antenna tests using Whisper, and I hope to bring you some videos of it soon.